Collaborative Analytics broader workstream meeting. We'll get started in a minute. We'll just allow a few more folks to join. I think we have a pretty good quorum. Thanks everyone for joining. This is the N3C Collaborative Analytics broader workstream meeting. We have a pretty packed agenda, so I think we can go ahead and get started. Justin, do you want to run us through our agenda and the meeting?
Yep. Yeah, thanks, Usman. Yeah, we do have a packed agenda today. Here's what we'll be covering. So we'll start with a brief reminder of the governance and DUA structure that will be governing the N3C effort. We'll give an update on Palantir training. Peter Robinson and Joe Saltz will give an update on the clinical scenarios and data analytics subgroup. Philip Payne will be talking about the synthetic data pilot that he's leading. Melissa will be discussing hash strategy and how to link across different data sets. And if time, I'd like to present the COVID-19 Dream Challenge that launched last week that I think has relevance to this group. So let's go ahead and get started. Just a reminder, we have 4 work streams. This is the collaborative analytics work stream. Let me briefly remind everyone about the DUA principles for limited data set. That they'll be governing, how we how we're stewards of the N3C data. So this data set is designed for the analysis of COVID-related questions. No re-identification of patients or contacting of patients will be allowed. It'll only be allowed for research, public health, and development of COVID-related questions. The limited data set is a technical term. It's perhaps somewhat of a misnomer. Limited data sets means that there will be some limited PHI contained in this data set. Specifically, here will be geolocation and dates. So the requirements for access of this limited data set, it'll be hosted, the data itself will be hosted on a secure data enclave. No data egress will be allowed. And hence the design of and use of the Palantir cloud environment to host all the analytics that will be used for the N3C initiative. It'll be used for a limited time period. For access to data, there'll be a DAC, IRB, and related requirements that I'll discuss on the next slide. Any findings will be shared back to the consortium and no secondary redistribution. So there will be a tiered data use. The limited data set, here we're talking about a row-level data access that will include dates and geolocation. Both a DAC and IRB will be required, DAC being the Data Access Committee. For analytics output, where we're not talking about row-level access, but access to the algorithms and applications that we intend to host on the N3C platform, a Data Access Committee approval will be required for that. And then access for the synthetic data that Philip will be talking about later. This can be widely distributed. There's low risk of de-identification, and only registration will be required to access this data. Ken, correct me if I've made any mistakes or mischaracterized. I realize this governance model is an evolving process, but I hope I got it correct here.
Justin, you're asking me? Yes, it's perfect.
Perfect. Okay, great. A brief update on the platform training. There have been some changes from what I announced last week. There's been a delay in some of the training, but I'm happy to announce that training will commence this Wednesday and Thursday for a targeted group of users. The way with the training will be structured will be two separate sessions. There'll be a fundamentals training and then a more advanced analytics training. The fundamentals training, this is recommended for everyone and is really kind of an overview of the platform, how to access it, how to upload data, how to navigate the platform, how to create workspaces, how to edit permissions and controls, how to conduct how to utilize different analysis tools, how to browse objects, find documentation, etc. So this is a training course that I think will be broadly interesting for most of the attendees on this call, and we hope to provide enough opportunities for everyone to be able to join and get this training. There's a separate session for the power users, those who need deeper instruction for the advanced analytics capabilities of this platform. And some of those topics are listed here to the right. So as I said, the first sessions will start this week. This will be for all fundamental training. And those who are signed up for this already know who they are. So these are unfortunately already filled. But we do have slots that are opening up next week, 2 slots for fundamentals training. And then there'll be a day on May 13th where we'll have slots for the advanced analytics, and that'll be for the people who complete the fundamentals training this week. There is a link, maybe Usman, if you can send out the slide, link to the slide deck, because this deck will contain a number of important links that people can use to access information.
Sounds good.
So this is an Excel spreadsheet form. So please, if you're interested for fundamental training on May 12th, please sign up for it. If it does fill up, Palantir has suggested they'll be able to open additional slots later in the week. So don't panic if it fills up and there's no more slots available. So just a few, for those who are taking the training this week, just a few prereq notes that Palantir wanted to share. First of all, they recommend having Google Chrome installed and working. We will be using the Azure Active Directory, so this will be a temporary measure to get accounts and to authenticate into the system using the Microsoft Authenticator app, which will be downloaded, which as you go through the process of logging in, it will ask you to download this app to provide two-factor authentication. This is only a temporary measure. In the longer term, we'll be integrating with login.gov, UNA, and Common. So this is really just to get a temporary training account for the purposes of this week and perhaps next week. Okay, I think that's the end of the training. Any questions? People, I think, could raise their hand. Is that right, Usman?
I am not seeing any
Okay.
questions just as yet.
Justin, this is Chen Lei. I have a quick question on the training. So say like if I already signed up both like fundamental and advanced training. So later, like if I have like for example, a new member in my team, I want to bring him to work on this, and is it later people will require to sign up those training, or is basically because I took those training, I will basically train the next person to be involved in this platform?
I think I think that is the bigger plan is to have enough of us kind of train with the system that we can help train the next generation. But I think for for at least the next few weeks, I think we will have ongoing training through Palantir to get us onboarded and familiar with the system.
Hey,
So
this is Sorry to interrupt. This is Nabil from Palantir. Yeah, so in addition to that, so we'll be hosting trainings every week for as long as people need in this group. There are also sort of self-trainings and tutorials inside the platform that any new person can access without having to join a training if they don't want to as well.
That's great. Perfect. Yeah, thank you.
Thanks, Nabil. Okay, if there's no more questions with training, and this is very exciting because I think we've all been waiting to learn more about the platform and how it can support this work stream. Okay, so work stream subgroups, we introduced them last week. There's 3 different subgroups, the portals and dashboards led by Dave Eichmann, Warren Kibbe. They have a meeting time, Tuesday, 10 a.m. Eastern, every week. The tools and resources subgroup led by Chun-Li Wu at Scripps and Andrew Williams at Tufts. Their meeting time is Friday, 4 p.m. Eastern time. The clinical scenarios and data analytics group led by Peter Robinson at JAX, Heidi Spratt, University of Texas, and Tel Bennett of University of Colorado. Their meeting time is weekly, Monday, 11 a.m. Eastern time. If you're interested in joining these groups, we ask that you fill out this form. Again, this is a clickable link, and that'll provide you information of how to get Zoom information and signed in for those subgroup activities. Okay. So now I'm going to hand it over to Joel Saltz, who will talk about some of the activities of the clinical scenarios and data analytics subgroup. Joel?
Okay, thanks. So so we're really just getting launched, but we've been going back and forth and sort of deciding what we're actually going to do. And so there are a number of efforts that need to be carried out in order to kind of move forward with this. And so one of the things that we need to do is to define clinical scenarios, as you know about. And the next slide, we'll get into some examples of that. And I guess I'm just learning about this whole effort myself, so I guess I'm also going to be joining the clinical scenarios group to help with this in an official sense. The next is to develop and deploy pipelines to map electronic health record data to COVID-19 data elements. And this, of course, really complements some of the work that's being done by the other work streams. To some degree, it may be that it'll all be done perfectly, but at least at Stony Brook, in our work with our internal COVID data commons, we found that there's a certain amount of decoding of what, at least to us, were somewhat idiosyncratic variables having to do with respiratory, ventilator settings and high flow oxygen and the like, that may or may not be mapped in a sort of COVID friendly way. I think that, and I think I mentioned this the last time, we'll be working with the other work streams so that if these things aren't part of the standard OMOP mappings, I'm sure they will ultimately become. But certainly out of the box, a lot of these things don't seem to be supported with the current infrastructure. Developing curated data elements around outcome and progression. Obviously, COVID-19 has idiosyncratic and often very horrible course, and so nailing down what the criteria are for defining progression and defining when people are getting better is, again, something that people, I think, understand increasingly well, but making sure that we nail down the electronic health record variables and do this consistently across different vendors is important. Collaborate with the portal and dashboard subgroup to support exploration of the core data set using cohort discovery tools. So basically, once we generate beautiful curated data sets, then we want to be able to make this information available. And as I understand, LEAF is one of the tools that the consortium's interested in. Certainly, Trinetics is another. See, I skipped the issue of temporal evolution, which is of course very important, making sure that we develop good methods of characterizing and mapping this, and then collaborating with the tools and resources subgroup to select and configure tools that are driven by clinical scenarios, and then to implement a modest number of example analysis pipelines that target both statistical and machine learning approaches. And again, these are things that we're doing at Stony Brook, and I'm sure many of the other people on the call are doing at their own sites. So I think that'll be worthwhile to bring to the rest of the world. Next slide, please. So a group of us, in particular Peter, Justin, and I, sort of went through and nailed down some examples of clinical scenarios, actually in the context of discussing a VA collaboration. And so I suggested that just as examples of some of the things that we're talking about, to talk about them here. So here are a few examples, and this is obviously by no means exhaustive, and these are very high level. So what are clinical phenotypes that have good, medium, worst outcomes? So basically people come in with various comorbidities and with various symptoms, and to what degree can we predict how patients with a set of combined hypertension, diabetes, coronary artery disease, cerebrovascular disease, past history of renal disorders and the like, how will they do? Social determinants of health. Certainly, it's well understood that there are substantial, huge disparities in who gets sick and perhaps how they do. So can we understand that better? What are regional differences in outcome as a function of various different variables having to do with urban density, the nature of cities, type of hospital, a relationship between psychiatric illnesses. PTSD was the one that we were discussing in the context of the VA. It could be more broadly relevant. Relationship between cancer history, cancer therapy, and disease presentation and evolution. Obviously, cancer therapy, you understand there'd be some predictive power in cancer history likely as well. Well-known issues with hypertension therapy due to the ACE2 sort of story, COVID incidence, disease course, and then a bunch of predictive analytics with one of the areas that I understand, well, actually both our group at Stony Brook, because some of our closest clinical collaborators are actually nephrologists, and I understand that this is interesting to a broader group, essentially development of AKI, renal failure, and of course hypercoagulability. So predict which patients are most likely to develop these problems and develop analytics that provide early warning. And it is interesting because there were an awful lot of groups thinking along those lines. Within our own institution, we had a seed grant, COVID-19 grant competition, and one of the groups actually that we're working with proposed just this. So it was actually interesting. Great minds think alike, I suppose. And methods to predict response to COVID-19 therapies. So these are some examples, and it's an incredible data set, and it's really a fantastic group of people. So I think this is hopefully gives some sort of taste of some of the things that people are thinking about. Okay, so Justin, I'll hand it back to you.
Actually, I'm going to pass it on to Peter.
Yeah, hi. Yeah, thanks, Joel, for the excellent report. I don't have too much to add, but I would say that in the group meetings that we have every Monday at 11 o'clock Eastern, we now want to start to talk about about implementing this in a concrete way. And we plan to spend the next 2 weeks talking about AKI and respiratory failure. and would welcome computational or clinical or research people to join the conversation. The goal really will be to make concrete plans to implement what Joel just presented. So I'll give it back to Justin right now.
Great, Peter.
Hey, Justin, there is a question in the Q&A. It is from Carrie. She wants to know, many of the variables needed for the phenotypes will be only in clinical notes, nightmares, sleep issues, social determinants, etc. Are you planning to include any data mined from clinical notes?
I think that goes upstream of this group. I do know that there are a number of people discussing, including some on this call, who have been interested in tackling that problem and how they would be able to integrate and help with extraction from notes and be part of the part of the data transfer. I don't know if there's someone from a work stream who's upstream who might have more concrete knowledge of any efforts underway.
Yeah, this is Chris. As we all know, all the common data models are working to increase the fidelity of the data that they're collecting with COVID. Virtually all the common data models have a COVID subset, which in many cases does include some NLP elements. I can say that at least in the first several weeks and perhaps the month of N3C operation, we are taking the vanilla clinical data model feeds from sites and getting the machinery running. Some sites may choose to send us the data from their COVID specific registries simply because they're refreshed more frequently. And that may or may not include data that has been harvested from NLP. But a concerted NLP effort probably wouldn't occur until a few months down the pike as far as regular data feeds are concerned.
Thanks, Chris.
And there's another question, Justin, I can read it for you. Will there be an effort to specify the number of patients in the N3C cohort needed to address the questions defined in the clinical scenarios? This might motivate sites that are considering sharing data. I think maybe Ken, no, that's a different answer.
Yeah, I mean, go ahead, Peter.
Yes, indeed, we have been talking about that, and as you know, some investigations are good for a traditional power analysis. Others perhaps a little bit more difficult. But as soon as we get started, yes, indeed, we will be trying to do some power analysis and try to figure out how many patients we would need to address certain questions.
Okay, great. So I think the clinical scenarios group is the right place for the fine-grained discussions here. So really encourage anyone who's interested in those conversations to please sign up for that subgroup. Why don't we go ahead and move forward? And I hope at the end of this call we'll have more time for Q&A. So Philip, I think you might be on the attendee side, need to be promoted to the panelist side. If you can help with that, we can get Philip presenting.
Yes, so I think Connor needs to.
I just promoted him.
All right, thank you.
All right, can you hear me okay?
Yes, we can. Great.
Great. And I do enjoy the part where when you get promoted to a panelist, it briefly disconnects. So it's like a moment of fear followed by the opportunity to present. So I'm going to spend just a couple minutes talking about a emergent part of the overall N3C initiative, which is to build a synthetic clinical data set that will be useful for a variety of applications, and I'll get into it in just a moment. So if we can go to the next slide. Yeah. So just briefly, and it would be beyond the scope of sort of this particular presentation, and I'm happy to unpack this with people, that we are partnering with a startup company named MD Clone. Some of you heard me talk about them before. They have a unique platform for producing computationally derived synthetic clinical data. And sort of the short version of this is that for any given data set, you can engage in a process of defining a cohort based on some phenotypic criteria, select a set of features that are available in that data set for that cohort, and then produce an on-demand synthetic derivative that can either be analyzed within the environment to produce summary statistics and visualization, but also can be exported for subsequent analyses. And I'm often asked sort of, how does this work? This is the abridged version. If you imagine within that cohort a set of features that define the individual patients within the cohort, for each one of those features, there is a set of measurements that exist within a feature space. And that feature space has some sort of density function that sort of explains sort of the relative distribution of those measures for individual patients. And you can then imagine that each one of those patients becomes a vector that passes through this multidimensional feature space. So if we advance to the next part of this slide. And again, in the MD clone platform, what happens is that through a process of, again, vector manipulation, a new set of vectors are produced whereby each of the individual measures are non-overlapping with the original measures, but statistically similar enough that if you were to perform an analysis on the synthetic data set, you would get the same basic statistical features as you would if you performed the analysis on the original data. So what you end up with is a set of new vectors passing through the multidimensional feature space that are statistically indecipherable from the original patients from which they were trained, and have the added benefit of not crossing over in between the vector spaces, thus not having any substantial or significant mutual information, and therefore eliminating the possibility of re-identification of the original patients from whom that data was derived. So if we go to the next slide, what we are proposing to do here is actually to produce an environment that will allow for data contributors to load their data into the MD clone platform. It uses a Hadoop-based data lake as sort of the landing zone, and then has a longitudinal data model. That in turn will be accessed through the synthetic engine, which has both a query portal where cohort discovery operations can take place, but also the ability to produce synthetic exports that can be accessed in a variety of ways, much as Justin alluded to earlier with his points of conversation around the various levels of data access and data use and governance processes. But one of the really important components here is that there will be a process whereby data contributors in N3C who are contributing a limited data set will have the ability to have that data transferred into the synthetic environment based upon their data transfer agreements with NCATS. And similarly, based on the data use agreements that are being used for various end user communities, those synthetic exports can be moved into the Palantir environment for analysis in a cloud-based sandbox. And we are working right now on some of the more fine-grained data governance and master data management issues that will align these activities across these two work streams. But again, this is a subset of the overall N3C initiative. Initially, we'll have a smaller number of participating sites that will pilot, and then our goal is to expand over time as we gain more familiarity with this particular process. And then if we go to the next slide. Just to sort of get into a little bit more detail on sort of the basic sort of technology stack here, the idea is each data provider will be producing a limited data set that adheres to the overall N3C minimum data set definition. We'll be leveraging sort of the ETL pipelines and specifications that our harmonization group will be producing. This data will in turn be loaded into the MD clone data lake, as I talked about before. This will all be running in Microsoft Azure, working with NCATS IT and Microsoft, and as well as a collaboration with Microsoft Research. There will be the capability to perform data QA and profiling for the contents of the data lake. And then as I described, sort of two different tiers of access, both a catalog of standard extracts that are produced with the synthetic engine, not dissimilar to what you might experience using sort of synthetic data sets such as the Mimic data set, if you're familiar, and then sort of tier 2 users, which will have a higher level of sort of oversight and governance, whereby they'll be able to execute live queries against the environment and perform ad hoc extracts, and this will be integrated into the overall user portal experience for N3C, including all the other user management training and sort of interaction tools that surround that. I had actually edited this slide briefly before, but I don't think I made the cut. I would share with everybody, there's also a new work stream being spun up. We actually just had a discussion about that earlier today, and we will be bringing together the community of end users, of course, that are interested in this particular subset of the overall N3C initiative through that new work stream. So I would encourage everyone to stay tuned for details. Lots of sort of technical and governance and policy blocking and tackling taking place to sort of pull all these dimensions together. And that is my last slide. So I can either wait to the end or answer any burning questions now.
I think there's one in the QA.
Yeah, I'm just pulling up the box. Yep. What metrics will be used to measure the goodness of this MD clone data? So I'm moving backwards. So we have done a number of head-to-head comparison studies already using MD clone synthetic data and comparing that to the original source clinical data from which it was derived. We've done studies that involve either standard statistical characterization and comparison of data. We've used it for machine learning purposes, and we've used it for geospatial reasoning. And in all those cases have been able to share as a result of that there is not a statistically significant difference in the descriptive statistics, that we can train machine learning algorithms on synthetic data and run them in operation on clinical data and get comparable results, and that the geospatial analyses are identical as well. We continue to push that, and part of this project will actually be to use the driving use cases from N3C to continue to demonstrate the utility of this data set. I will share it's not a panacea. It's good for cohorts with well understood features across a feature space that's relatively well characterized. It does actually censor data in edge cases that can be a challenge in terms of not having mutual information that would render re-identifiable. And I'm happy to share offline. I see another question from somebody that's in here as an anonymous attendee. We have a set of initial case studies that actually show this head-to-head comparison of the platform, and we're happy to share those details. And again, part of this project will be continuing to demonstrate the utility of the synthetic data.
Any additional questions? All right, thanks, Philip. We have a last-minute addition to the agenda. So, Melissa, you want to talk about the hash?
Yeah, and I'm gonna call on Emily because she did such a nice job explaining the hash on our earlier phenotype call last week. So she has a couple of slides that she can throw up and give a quick overview. But so if you can hand it over to her, that would be fantastic. And meanwhile, I'll give an update on what we're going to try to do here. So our hope is that the N3C is solely focused on EHR data at present, but fully recognizes that there are huge opportunities if we can connect data that is coming into other sources. Specifically, key examples are imaging data and genomic data, both viral as well as host genomes. And so ideally we could create a system whereby whenever anybody submits to N3C, there's a hash, and we'll talk about what that means here for those that are less familiar, that can then be used to connect to those data so that we can do multimodal analytics with data in those other contexts. And so our hope today is to kind of just come up with a few volunteers. We're looking, there are a plethora of different hashing strategies. We're not, we really just need to pick one of them and then run it through our governance group to make sure that we're meeting the regulatory requirements as well as community needs. It doesn't necessarily have to be all that complicated. We also need to take into account the hashing strategies that are already used by many other organizations, such as the ACR, which we've been working closely with on some of the imaging conversations. So I'm going to hand it over to Emily to just give a very quick overview. I don't think we need to spend too much time, but just so people know what it is, and then we're essentially looking for a few volunteers to kind of hash out the hashing plan, and then come report back to this group as well as to the governance group.
Great, can everybody hear me okay?
Yeah.
Awesome. So I am Emily Path. For those of you I haven't met, I'm at UNC Chapel Hill. And for N3C, I'm leading the phenotype and data acquisition work group. So it's the work group that is, I guess, upstream from this particular work group, where we are identifying the cohort and then extracting all of the data for the cohort and helping sites to submit those data to N3C staging environment. Because of that, we're also an ideal step in the process to consider this idea of hashing And this is an overview that I gave on the Friday phenotype and data acquisition call, so apologies if you've seen this already. But I'm just going to go over what we think this process could look like, obviously with some tweaks and changes that are specific to N3C. So the first step in doing one of these hashing projects, and again, I'll explain what hashing is if that's not a familiar term for you, is that we need to extract identifiers at local sites. So behind local firewalls, an analyst can extract identifiers for patients that are potentially linkable. Most things are linkable in combination, right? So you wouldn't just use somebody's first name to link with the people in another data set. That's not specific enough. So we need to come up with lots of different combinations of identifiers that could be used to link from data set A to data set B. But in this extraction process, there is some measure of data cleaning that's necessary always in projects like this. And it entails things like removing junior and senior and the third after people's names, middle initials, that kind of stuff. So that should happen at the sites. And then this fully identified table that does contain full identifiers, it is sensitive data, it will always remain at the site behind the firewall. The second step is where the hashing comes in. So a hash is like a fingerprint for data, and each hash uniquely identifies strings of letters and numbers, but obscures the actual letters and numbers. So I have sort of a toy example here in the figure where we're using the hash function that's in the box there to convert the name Tommy, using that formula to the number 171. And in my toy example, 171 uniquely identifies the person named Tommy, but we can't get back to the name Tommy from 171. So hash functions can be very simple, like the one that you see here, and that we would never use in a production environment, or extremely complex and very secure. And what's even more secure is a one-way hash that involves a secret key, which is a type of hash function that allows the data owner to hash the data such that the data cannot be reinterpreted back into the original data, and also was hashed using a key, a number maybe, that only the data owner knows. And in that way, there's no way for anyone, any bad actor, to try and reverse engineer the hash if they're looking for a particular person in the data. So that is absolutely the strategy in general that we would recommend for a project like this. And as Melissa mentioned, there's lots of different ways to do this. But this is certainly the direction that we want to go.
And Emily, I'm sorry, this
Yes.
is Ken. So could you also talk a little bit about if somebody wanted to do linkage, they would actually, can you explain how they would contact the site who would then ask a third party to unveil the hash? So the request has to go back to the site, right?
Yeah, yes, exactly. So I think I get to that in a bit. Let me just, let me make sure. Well, I'll just go over it now, which is that if we would not be expecting sites to send their hashed identifiers to the central repository other than on a case-by-case, study-by-study basis. So it would have to be a situation where there was a particular data set that wanted to link with N3C, and sites would be given the opportunity to participate in that linkage. And if they chose to participate, then that's when this hash linkage process that we're talking about would occur. Now, there's no reason that a site couldn't run the hash table as I've described and keep it behind their firewall at the site and just never do anything with it until the time came where they wanted to participate in a linkage study. Does that answer your question, Ken?
Yes, thank you.
Great. So once we have identified our hash function, and in our case, we've used SHA-256 a lot, which is one that is very commonly used in projects like this. Once that's identified and everyone agrees on that, then still behind the firewall, the analyst at the site can apply that function to different combinations of the identifiers in the data set. And I have this illustrated in the figure here, where you can see that we're trying to smash together various combinations of these identifiers in order to try to make one that is most likely to match the other data set while limiting false positive matches as much as possible. So, as I mentioned, if you just match on first and last name, there are certainly other Emily paths out there in the world, so that would not be a good combination of identifiers to use. But if we add in date of birth and first 3 digits of zip code, then that actually might get us somewhere. So what we would normally do in a project like this is agree on the combinations of identifiers that we want to use, make sure that all of those identifiers are available and reliable on both sides of the equation. So the site needs to have them and the third-party data set needs to have them. And then we can try a few different combinations and see which works best. So at this point, assuming everybody's agreed to participate, the site analyst can now send a file that only contains the hashes to the central repository, as well as a crosswalk to a dummy ID that will eventually be able to link to a patient ID that's in N3C. But we never have to send any actual identifiers for these patients through in this process. And each hash is a single person on the site-side file. And the only exception to that is that if multiple identifier combinations are tried, as in we're not just using one combination, then there will be multiple hashes per patient. Now, the site analyst will need to retain a crosswalk file so that if there is any need in the future, after the study gets going, to re-identify patients, that the site will be able to trace back, patient XYZ to their original patient identifier. But those crosswalk files will always, again, remain behind the firewall. Now, this is where the owner of the second data set comes in, because the owner of the second data set is going to have to go through all the steps that I just mentioned, but on their data set, because that's the only way that there can be 2 hashes that match. So the owner of the second data set needs to know the hash function, they need to know the secret key, and then they can repeat the hashing process on their own data set. And then that person will repeat all the steps, generate their own crosswalk, and can also submit their hash crosswalk file to the central repository. And then the final step is to look for matches. So the hash files from both sides can be compared with each other. And if 2 hashes match, we are going to assume that the person represented by that hash is the same person. And then once matching is completed, you can go forward with whatever analysis you were planning on doing once you know who's who in each data set. So based on prior work, and again, there has been a lot of prior work in this area, so we certainly do not want to reinvent the wheel. We want to go off of what has proven to work well in the literature and in other work that's been done by some of these common data model networks. So we're proposing, just as a straw man, the selection of identifiers for the behind the firewall tables, which would include first and last name, cleaned, date of birth, zip code, and gender. I do not have social security number there because it has actually not been shown to be that much more effective in linkage than not having it. And it's also sort of a radioactive data element, so avoiding it is not a bad thing if it's not a huge value add. Now remember that these identifiers can be combined in different ways, and we can also use functions like SoundX so that we can find matches even if there are minor misspellings. And so what the idea is for the phenotyping workstream to include in our code that we're giving to sites, code to enable sites to do this really easily and not have to come up with their own methods of doing this. But as Melissa mentioned, we need contributions from, first of all, people who are interested in this topic, but maybe most importantly, data stewards of data sets that think that they would like to link in with N3C. Because it's really important for us to understand, first of all, what identifiers are available in those other data sets so that we know what we're linking with, as well as any caveats or anything that we need to be aware of in order to make this hashing as successful as possible. And happy to answer any questions that anyone may have.
Well, I would add, Emily, the comment about a secret seed that would be shared with collaborating organizations to avoid brute force efforts at re-identification.
Yeah, that was the secret key that I had mentioned earlier, that the sites would know and the collaborator trying to match with the sites would know, but no one else would know.
So there's a question from Hiroki. This is probably a question for the NCATS team, whether or not the hashing that's used by NCATS Rare Disease Group could potentially be used here. Have you guys talked to each other about that yet? I'm not sure if we have the right people on the call.
Yeah, I'm not familiar with that, but I would love to learn more about that.
Yep. So that would be, so let's definitely follow up on that. So basically, just in the interest of time, if you are either a hashing expert or you have a data source that you would like to connect to N3C and would like to participate in figuring out what the hashing strategy might look like, can you just let me know, and we'll try to put together a small group to try to lay out a plan. That plan will then go to the governance group for review, and then we'll bring it back here and let everybody know what we think the best plan will be. Back to you, Justin, unless there's any other questions.
I have a quick question, Emily. Based on the slide that you were just showing, where hash from one site was compared with the hash from another site, was that a comparison between two sites or within the same site? I was just a little confused.
That was representing a comparison from data that would be from sites in the N3C repository with data from a third-party data set, like, for example, an imaging data set that wouldn't be part of the site loads to N3C, but is a data set that may need to be linked in with N3C.
Okay, because the keys that are sent to the central repository, right? Once a hash is created, and then you have your secret key, and then you create a random number out of that, and that's what is going to be sent to these N3C, right?
That is correct.
Okay, so.
But only on a study-by-study basis is my impression, because not every site may wish to participate in every linkage possible.
Okay. I mean, I'm just thinking out loud. When I saw the picture, I misunderstood that it was comparing between patient from one site against a patient from another site. But that's not possible because each site would have its own secret key. So the output from both sides, even though they use the same hash algorithm, because the secret key is different, the output would be different.
You could have a shared secret key that was a shared secret if that was the way that N3C wanted to proceed. And I'm glad you're bringing up questions like this, because these are exactly the reason that I think we need this work group to answer very valuable questions like that. I think it's important that folks who have a lot of experience with this help to make the decisions as to how we want to do this.
Okay, thanks, Emily.
Thanks, Emily.
Sure.
Is my screen showing again? Do you see EHR Dream Challenge?
Not yet.
Not yet.
There's one question in the Q&A about hashing. A patient will have multiple hashes. Are there matching probabilities provided?
It's a little hard to provide probabilities without a gold standard, but there are studies in the literature that have those probabilities for various combinations, and I would certainly plan to look at those as we decided on what combinations to use.
Okay, so in just the 10 minutes we have left, I'll give a very abridged introduction to the EHR Dream Challenge focused on COVID-19. If you're interested, you can access this information at dreamchallenges.org or go to our CD2H website, which would provide direct links to sign up and learn more. Basically, the idea of the COVID-19 challenge is can we use EHR data to answer clinical questions and to benchmark different approaches. This is in partnership with the University of Washington, who's we've worked very closely with to curate and annotate a data set to be used in this challenge. And essentially, we'd like to be able to ingest algorithms that can predict transition states, as shown here, going from diagnosis to hospitalization to ICU to intubation and perhaps death. And so based on using information from the EHRs, can we predict these transition states? I'd like to emphasize this is not a traditional challenge in the sense we are not looking for winners or losers. What we're really trying to do is provide a mechanism for the external world to be able to participate and test their models, their hypothesis, using a real COVID patient cohort, and develop rigorous benchmarks with respect to how these algorithms perform. And I believe that this could be an approach for this group to consider as a way to perform large-scale analytics once we have our N3C database up and running. The structure of this of the data itself, the data cohort itself, is an extract out of the University of Washington Electronic Data Warehouse. Goes back to 2009, where the extraction is very similar to what's being done for N3C and identifying COVID-tested patients, which is being deposited into an OMOP repository and has all the the expected measures that align with OMOP. We are also doing a parallel effort to curate chest X-rays, and so that's a process that's happening now in de-identifying those images, and so there will be a parallel track where we ask these same clinical questions, where chest X-rays will be available. They're not available at this moment, however. This launched last week. And I think that the best way to kind of motivate how this is structured is to point to a challenge we actually just completed. This is also with University of Washington. We call this the Patient Mortality Prediction Challenge. It completed just a few weeks ago, and I think by running through this, the structure of this challenge will help you understand how we're structuring the COVID challenge. This challenge asked participants to predict which patients would expire within 6 months of their last visit. The data was, again, the University of Washington EHR Data Warehouse had over 1.3 million patients with at least one visit. That was 22 million visits altogether. And again, we used the OMOP Common Data Model for this challenge. The way this challenge was structured, in the same way we're structuring the COVID challenge, is a two-phased approach where you submit your model as a Dockerized container. It's then applied on a synthetic data. This is a SynPuff dataset that many of you might be familiar with, to stress test the model on this synthetic data. If there are errors, we can return your log files and all the results, because it's synthetic data and there's no risk of sharing PHI. Once it passes that check, the model then moves forward to the on-prem compute environment at University of Washington, where it's then applied to their data set and we can evaluate its performance. That performance is then returned to a leaderboard that's shared with all participants in the challenge. One of the nice things about this challenge, and this will apply for the COVID challenge as well, is we have examples of how to create a model. So this is both in Python and R. You can follow this, the scripts, they're all in GitHub. They show you how to both write the model and how to Dockerize it and submit it. And I think it's a great training opportunity and exercise, especially for those who are not familiar with OMOP. If you're not familiar with how to encode predictive models, if you're not familiar with Docker, I think all of this apparatus is a great experience for those who are trying to get up to speed in developing analytic models applied to EHR data. For this challenge, we had a number of rounds in the final validation phase, which I said we just completed, and in fact the results of the validation I believe are being sent out today. So this group might even have a couple hour head start, and the final results of this challenge, which are shown here. The two metrics we used were the area under the ROC curve and the area under the precision recall curve. And you can see the top team there. That's not University of Washington. This University of Wisconsin Biostat group. And I think this really demonstrates the feasibility of this approach. So people never had direct access to the data. This was not a data set that we distributed to participants. They had to submit a full working algorithm that we applied on their behalf. And you can see the area under the ROC curves, they're very, very high, 0.94 for the top team, and a very high area under the precision recall curve as well. So I think this is really underscores the feasibility of this approach, and I think will work very well with the COVID-19 challenge as well. This just shows how the teams have how their performance improved over time both with the area under the RSC and the area under the precision recall. The final, I should add that the final validation phase uses a completely independent cohort. This was collected prospectively after the launch of the challenge. So I think that's another important and novel aspect of both this challenge and the COVID challenge, is that we'll be able to track performance over time and see how things might change just depending on the change in the underlying patient population or changes in the models themselves. So with that, I just want to, if you're interested, again, please visit dreamchallenges.org or covidcd2h.org. I think this is, again, just a great way to educate yourself about developing models for this type of data. And I hope that it'll spur some of our own thinking about how we want to reach the broader community, where people don't need to necessarily have a DUA or an IRB, but can still submit a model and that can be applied to the N3C data, where we can develop rigorous benchmarks and assessments and share that with the community. So with that, I will stop. We have 4 minutes left. That's great. Just as a reminder, here's important links to join the conversation: Slack channels, Google groups, and we have links throughout the entire deck. So hopefully you'll be able to find what you need. So let's go ahead and see if there's any questions. I don't see any questions.
This is Warren, just making a comment, not a question. This is a really wonderful way to think about exposing very detailed data without actually exposing very detailed data.
I agree. It's another paradigm in our data sharing toolbox. So not everyone's going to be able to get a DUA and IRB. So this, I think, will broaden the reach. Okay. I'm having trouble.
I believe there's one more question.
Could you read it, Usman? I can't access it.
Yeah, it's by Sean O'Neill. Is it possible to practice with the OMOP data even though the challenge is closed?
So the EHR challenge, the patient mortality is closed, but the COVID-19 is open. But we will, with respect to the patient mortality, we may keep it open just for people to continue to test and submit their models. But yeah, I'm not sure we've considered that yet. There's another question I see.
Yeah. Is the COVID Dream Challenge data synthetic or original?
So this is the real data. This is right out of the EHR system. And it does have limited PHI similar to N3C. There will be geolocations and dates available.
Hey, Justin, this is Tim.
Yeah, hi, Tim.
I just wanted to clarify really quick. So the COVID challenge is open for registration and not yet for submission of models. And then I guess we can discuss later if we want to make the mortality prediction pipeline open for people just to play around in. I guess that's a discussion we're gonna have later. It's just in reference to that previous question.
Yep. That's Tim Berkowitz, who's has been a leader in putting together the COVID challenge and the patient mortality. And I really want to give a shout out to the University of Washington team, Adam Wilcox and Sean Mooney, who and all the team that's been helping put that data set together.
Yeah, this is Mike Bisich. I dropped a question into the question box, but you unmuted me, so I'll just say it. You know, the role of hashing and the use of both open source and commercial tools for hashing has been addressed by the PCORI network. Has there been any communication with the team to see how quickly or what lessons learned could have come from those experiences in the approach you're taking for N3C?
This is Emily. I can comment on that. So I was involved in the vendor selection process for the PCORNet hashing vendor selection, and am now as a site absolutely contributing to the hash token table, which throughout PCORNet, if those of you who aren't on PCORNet yourselves is the table that allows the function that I was going over to be instituted throughout the CoreNet network. So the answer to your question is absolutely. We learned a lot of lessons in that process, and certainly want to take those lessons and not make the same mistakes again.
Yeah, so again, just from the fresh scar tissue from those efforts, you know, it took about 3 cycles to get this through and adopted in the Picori network, first with an open source set of tools, then with a small commercial entity, and then with a larger commercial entity. And it took about 2 years in the process to get it through the whole network. And obviously, things are moving faster because of COVID. And the current issue that Emily's talking about, and I'm glad, Emily, you have experience there, still isn't completely baked because of the governance issue that has to follow once a tool set is adopted. And I just wanted to make sure you were aware that there is a rich experience, again, from Picori to draw from as you move forward with this, so that unanticipated or anticipated governance issues don't arise in the march to doing the good work you propose here.
Yeah, I couldn't agree more with that. And I think especially it's important for us to remember that the technical pieces of this really, in many cases, are not the hard part. It's the governance stuff. And Picori has a ton of experience there too. So completely agree.
And I think the key issue, again,
Right down.
For the CTSA source data is to quickly assemble an education piece for the PIs and the sites that have to sort out or considering the framework. And as you put these supplements out through the NOCI, to make sure that if the government will allow this, of course, that the PIs and the groups agree to the path towards using these hashes as part of it. And certainly the RFA isn't specified enough to include things like that. But you know, the last thing you want to do is go through a quick selection process, bring people on, get the agreements, and then have the PI say, "Oh, our legal won't accept this." On the rush, on the other hand, to supplements, if that's done as part of the pre-funding, then it will remove a barrier. And I assure you, this is a success factor you might want to consider.
Okay, thanks, Mike, and thanks, Emily. I think we're at the top of the hour, so we're going to go ahead and conclude. So thank you, everyone, for your attention.
Thanks a lot. Have a good day.
Thanks, everybody. See you in the ethers.